Hi, and welcome to this explainer video going through rates of reaction, including collision theory and the different factors that affect the rate. So as you can see on your screen, I've got a little bit of information about collision theory that I'm going to talk you through and then go through each of the four factors. Okay, so collision theory is a key part of chemistry and it explains why reactions happen or why reactions don't happen. So what we have is atoms and molecules colliding all of the time, especially in gases. So if you think about the gases in the air, those particles or atoms are bouncing off each other all of the time, but they are not reacting. And this is because of this here. So particles will collide and will only react if they have the activation energy. And that is the minimum amount of energy that they need to break their bonds as they collide. If they have the activation energy, then their bonds will break, which will cause a reaction to happen and produce new products. This is what directly affects the rate of reaction. So if particles don't have enough activation energy, they can't break their bonds and they can't react, which would mean that the rate of that reaction would be very slow. We can calculate rate of reaction using this calculation here. So what we have is rate equals the amount of reactant used or amount of product formed over time taken. Now this line here, just to make you all aware, means to divide. What that means is the unit for rate of reaction will change depending on your measurement. So if you are measuring your product or your reactant in grams and your time in seconds, then your rate would be grams per second. However, if you were measuring your amount of product produced in volume, so we would do that in centimeters cubed per second, we would end up with cm3/s. So what you have to be careful of when you're calculating rate or looking at anything in particular to do with rate is making sure that you know that you have the mass or the volume and the correct unit of time to get your correct unit for rate. Okay, so I said before that there are four factors that we need to look at that affect the rate of a reaction. The first factor that we're going to look at is temperature. And so when we talk about temperature, what we're really talking about is the number of molecules that, again, have that key part, that activation energy. So if you increase the temperature of a reaction, particularly an endothermic one, this will not work if it's an exothermic. Okay, so if you increase the temperature of an endothermic reaction, what happens is the rate of reaction goes up. The increased temperature gives the molecules more energy. If they have more energy, more molecules will have this activation energy. If you have more molecules with activation energy, what will happen is as they collide, they are more likely to break their bonds, and so you get more reactions. So higher temperatures actually give us faster reactions, which means that if you increase the temp of a reaction, you increase the rate of that reaction. So a common thing in exams would be to give you a graph and ask you to show what's happening on that graph. So if we look at this graph here, there are two lines. We've got the first line here, which shows the reaction at a low temperature. And what we would say for this one is that the rate is low. That line is a gradual increase and not a fast increase. And so what we're seeing here is not many particles have activation energy, so when they collide, they don't really break their bonds and react. The other line that we have is this one here, and this one is representing a higher temperature, and what that shows is that the rate is high. What we have is a quick increase in product, and so we get a faster rate of reaction. What has happened is we've increased the temperature, we've given the particles more energy. When they've collided, they've had enough energy to break their bonds and so have reacted. Okay, so the second factor that we're going to look at is concentration. So concentration only works if we're talking about a solution. And when we talk about concentration, what we're actually looking at is the number of particles, okay? So if we think about it in this way, if particles are colliding all of the time, if we increase the number of particles in our solution, then we're going to increase the number of particles that can collide. So if we look at these two pictures here, this first picture is what we would call a low concentration. And what we can see there is there are fewer particles in this volume here, and so they have fewer reactions. They're colliding less because there are less particles, which means they're less likely to break their bonds and react. This solution right here, this is a high concentration. What we have done is we have increased the number of particles in that solution, and so as you can see, there are more successful collisions, which creates more reactions. Once again, we can represent this in graph form, and what we can see here is that we have a low rate if it's a low concentration because there are less particles. Whereas if we have our high concentration, we have a high rate because there are more particles. If there are more particles, they are more likely to collide. If they are more likely to collide, they are more likely to react. Okay, moving on to the third of our factors is pressure. And pressure acts in a similar way to concentration. However, pressure only works on gases. So what happens here is gases are spread out. So if we think about gas particles, they are spread out. There's lots of space in between them. If we put a gas particle under pressure, what happens is pressure forces the particles closer. So if we look at these two diagrams here, this diagram is under less pressure or a low pressure. And so what we can see is there are lots of gaps between our particles in the gas. That means that they are less likely to collide, and so they are less likely to react. If we look at this diagram here, however, this one is at a higher pressure. And so what that means is our particles have been pushed closer together. And when they've been pushed closer together, that means they are more likely to collide. And if there are more collisions, then they are more likely to react. If we look at our graph, like I've showed you before, if we have our low pressure, we have a low rate. And that is because particles are less likely to collide. If we look at this one here, we have a high rate, and we have a high rate because the particles are closer together and are more likely to collide. Okay, so one last factor that affects our rate of reaction, and that last factor is surface area. Surface area only works when we're talking about solids. So what would normally be done here is we would take a piece of solid, say for example marble chip or something like that, and we would crush it down, and by crushing it we turn it into a powder. What actually happens there is we take a solid like this, which has particles trapped in the middle here and an outer edge that can only react. So when something like this is reacting, what happens is our reactant particles will hit the edge of our marble chip like so and react with the atoms here. And once the atoms on the outside have gone, they'll react with the next layer of atoms and the next layer of atoms and the next layer of atoms until they're all gone. Now this takes a long time to do. So what happens with something like this is it would have a low rate because it has a low surface area. If we look at this, this is our crushed marble chip. What we've done is we've broken up the pieces, which has given us a bigger surface. Each one of these now has a surface that it can hit off to react. What that means is the solution particles have more area to bounce off and collide with. So we get more collisions, which means we actually get a faster rate. So this would have a high rate, and that's because it has a big surface area. If we look at our graph like we've done before, we can see that if we have a small surface area, we have a low rate, and it's that gradual increase again, and that's because there are less particles available to collide with, and so we get a slower rate of reaction. If we look at our bigger surface area, we would have a higher rate, and that is a faster increase in whatever we're producing. And that comes about because we have more surface for the collisions to happen over, so we are more likely to get reactions. Okay, guys, so just a reminder about this. Collision theory is all about how particles collide, and they will only react if they have enough energy to break their bonds, the activation energy. The rate of reaction is determined by 4 factors. The surface area. Big surface areas means more area for the collisions to happen over, which means more reactions. Higher temperatures gives more particles energy. If there are more particles with the activation energy, then they're more likely to react when they collide. And concentration and pressure bring particles closer together. In concentration, there are more particles in the solution, so they are more likely to collide, which means there are more likely to be successful collisions and reactions. In pressure, the pressure forces the particles in the gas closer together, so they are more likely to collide, which means they are more likely to react. That's everything in this video. I will be back with you again very soon to show you about how we calculate rate and how we measure rate.